Hello friends, and welcome to Webronaq. Today something genuinely big just dropped. Meta Superintelligence Labs shipped Muse Spark 1.1 this morning, July 9th, 2026, and it comes with a surprise. For the first time ever, Meta is charging businesses to access one of its own AI models through a paid developer API. That is a real pivot for a company that built its reputation on free, open-source llama models. But here is the question worth asking. Why does the architecture of this model matter as much as the business move? Because Muse Spark 1.1 is not just another large language model. It is an agentic AI model, and those two words change everything about what it can actually do. Let us break that down, from the ground up. Alright, so let us start with the big idea. A standard language model sits and waits. You send it a prompt, it generates a response, and it stops. That is it. It is stateless and reactive. An agentic AI model is something different. It can plan, take actions, observe the results, and then adjust based on what it finds. Think of it like the difference between asking a colleague a question and actually handing a project to that colleague. The first gets you an answer. The second gets you a completed task. Muse Spark 1.1 is built around that second idea. It can set sub-goals, call external tools, browse the web, and even operate software on your behalf. And here is the key mechanism behind all of that. A loop called the Plan, Act, Observe, Adjust cycle. The model forms a plan, executes an action, observes what happened, adjusts, and loops back. It keeps going until the task is done. Up next, let us look at exactly how Muse Spark 1.1 is architected to run that loop at scale. Alright, so how does Muse Spark 1.1 actually work under the hood? At its core, the model is built on a transformer architecture, just like most large language models today. But what makes it agentic is a second layer on top of that, a module Meta calls the Action Reasoning Transformer, or ART. While the base transformer handles language, ART handles decisions. It takes the current context and the model's goal, and it decides what tool to use next. Should the model search the web, write code, click a button? ART makes that call. The base transformer and ART run in a tight loop, each feeding information back to the other. And here is what makes this powerful. RT is trained separately on tool use data, so it is specialized for action, not just language. That two-layer design is what allows Muse Spark 1.1 to behave like an autonomous agent, rather than a simple text predictor. Next, we will see exactly what that looks like in practice. Here is exactly what that agentic loop looks like in the real world. In Meta's own demo, released today on July 9th, a user does just one thing, shoots a short smartphone video of a product they want to sell. From that point, Muse Spark 1.1 takes over completely. First, it processes the video and extracts the best photos, pulling out details about the item. Then it reasons about what a good listing needs, things like a title, a description, and a price. Next, it uses its built-in computer use capability to open a browser and navigate to Facebook Marketplace. Finally, it fills in the listing form and publishes it, all without the user clicking a single button. This is not a chatbot giving you instructions. This is the model doing the task. Perception, reasoning, and action, all in one, uninterrupted loop. And that combination is what sets Muse Spark 1.1 apart from a standard language model. Here is where things start to get really interesting. Muse Spark 1.1 does not just execute steps blindly. It watches its own progress and adjusts. This is called self-reflection, and it is what separates a brittle script from a genuine agent. Imagine the model opens a browser, but the page loads unexpectedly. Instead of stopping or returning an error, the model notices the problem, reasons about a fix, and tries a different approach. In AI research, this self-correcting loop is often described by the phrase observe, orient, decide, act, borrowed from military strategy. Muse Spark 1.1 applies that same cycle continuously. Each action produces an observation. The model orients itself to what it sees. It decides the next best step. Then it acts. If the action fails, it loops back and tries again. This inner loop is what makes agentic behavior genuinely robust. And it is the reason the Facebook Marketplace demo works end-to-end without human intervention. Next, we will bring it all together. Alright, let us bring it all together. The big idea in this video is a simple one. A standard language model answers questions. An agentic model gets things done. It plans, picks up tools, takes real actions, checks its progress, and loops until the goal is finished. Muse Spark 1.1, launched by Meta today, is a clear example of that shift happening at the frontier level. It can watch a video, reason about a task, operate a browser, and publish a result, all without you lifting a finger after the first prompt. And this is not just a Meta story. Anthropic, OpenAI, and others are all racing to define what agentic AI looks like at scale. The category is young, the benchmarks are still settling, and the best mental model to keep with you is this: plan, act, check, repeat. That loop is what separates the next generation of AI from everything that came before. Thanks for watching Webronaq, and we will see you in the next one.